So shall we start? Oh, we will be waiting. We will wait until some others come. We will just wait 2 or 3 minutes. Yep. Shall we start? Today, what we will be doing is just going through what we have done, and I will discuss some model questions or some questions in the particular book. We will be taking some questions from that book. And regarding the exam paper, there will be 2 parts in the exam, part A and part B. The time period will be 3 hours, and the part A may contain short questions. There may be questions to write short notes. So write short notes on the method of investigations, boreholes, what are the bush boring method, drilling methods, etc., and what are the foundation types, and what is this standard penetration test, likewise, and consolidation, compaction, etc. So that kind of questions will be there to write short notes, and then there will be a small question on the there will be the short questions on the consolidation, foundations, PT, and some ultimate bearing capacity, something like that. Then that is part A, and you will get 40 marks for the part A. All the questions in the part A has to be answered, and in the part B you will get 6 questions. Out of 6 questions, 6, 7, 8, 9, 11, 10, 11. Hello? Yes. In part A, you will get 4 questions. Sorry, the part A, you will get 40 marks. In part B, you have 6 questions. Question number 6 to 11. So from the six questions, you can select 4 questions, and I will tell you the topics on each question. The question number, there will be 5 questions in the part A, as I have mentioned earlier, and part B contains 6 questions, and out of 6 you will have to answer 4. The question number 6 will be based on the site investigations. So that will be based on the first lesson that we did, and the question number 7 will be based on the foundation design, and 8 that will be question number 8 that will be based on the foundation settlements and ultimate bearing capacity. Question number 9 that will be based on the consolidation, and 10 that will be based on the piles. Then question number 11, sheet piles, that is lateral earth pressure. So there will be some supplementary notes also. So that's it. That is the format of the paper. So today what we thought is just to go through some questions in just go through some questions or revision questions. So we will start a question from this Crown investigation. So this is Craig Soil Mechanics book. Wait, I will first share that with you. So that you can refer that. No? Craig Soil Mechanics book. So I have shared that with you. Right. So let me share the methods of investigation. So you can refer to the chapter number 10 here in the Craig Soil Mechanics book. So since we have discussed them earlier, I'm not going to explain them again. So a borehole log sheet is there. Yes. I will take one question from there. Right. So this will be a question. This is taken from a book, and read the question and try to find the answers for this one. I will give you just 5 minutes. So what is that top find? Yeah. So shall we read? Site. Is this recording? Yes. Site investigation is a fundamental process in construction and geotechnical engineering, providing critical information about subsurface conditions to guide project planning and design. It involves the systematic collection, appraisal, and assessment of soil, rock, and groundwater data to ensure safety, stability, and cost efficiency. Methods such as soil sampling, borehole drilling, and geophysical testing are commonly employed to identify potential risks like subsidence, soil stability, instability, or ground interference. The extent and the methods of the investigation depend on factors such as project complexity, the importance of the structure, and available preliminary data. By providing detailed knowledge of subsurface conditions, site investigation minimizes the construction uncertainties, optimizes design strategies, and prevent costly failures, making it an essential component of any successful engineering project. So even though you read this chapter or this sentences, you will not be given any answer for these questions. This chapter or this paragraph, This paragraph is only for an entrance to the question, right? Now, briefly explain main three groups of subsurface exploration methods. So what they ask is, what are the basic subsurface exploration methods? Basic three. So can you remember? What are the three methods or three groups or three types of subsurface exploration methods? Yes, if you cannot remember, please go through the notes and please tell me. Yes, what are the three methods? Ayyo. Manda. Yes, what are the three methods? Direct methods, indirect methods. Ayyo. ඔයාලා නිකන් ලොග් වෙලා යනවද නැත්නම්?
Direct, indirect, and semi-direct.
Right. Direct, indirect, and semi-direct. Yes. Now these three. So you have to explain that. What the question says is briefly explain. Now, not the state. State three or just write main three groups. Nothing. State main three groups. Then, if the question is just to write, oh, state main three groups, then you have to you just have to write the names. But here it says briefly explain. Right? So you have to explain this. Direct methods, indirect method, and the semi-direct method. So indirect methods, what we do is we measure or some other parameter, and what we do is we interpret the data to get the soil parameters. So these comprise geophysical methods, sounding methods. The stratigraphy is determined by surface measurements of changes in some certain some physical properties such as electrical resistivity, seismic wave, velocity, resistance to the penetration of a sounding rod. So we measure the other parameters and we come to conclusion or judgment of the other of the soil parameters by interpretation. And the direct methods and semi-direct methods. So you have to write this kind of paragraph or some briefly explanation, some 2 or 3 lines or 2 or 3 sentences for each. So if you have to read this and mark anything, I will just give you 2 minutes to read this. Right. So the next question, let's move to the next question. That is, explain about how you plan a site investigation for a building, or a reservoir, or a bridge, or another construction project you prefer. So this is an extraction from your what is it, assignment. So explain how you plan. In the next question, explain about which should be included in the site investigation report as chapters. Ah, so how you plan and how you report. So we have explained that how you plan in the exploration program. So reconnaissance survey, preliminary site investigation, then we move to the detailed site investigation. So you have to explain this during the reconnaissance survey what we do, and preliminary site investigation what we do, and during the detailed site investigation what we do. So likewise you will have to explain them, right? So what is reconnaissance survey? So please write I mean, there's no point of writing only these three. You have to explain them, because the question is to briefly explain. Reconnaissance survey, preliminary site investigation, and detailed site investigation. So the next question is based on this one. Before that, I will just keep this for 1 minute, 1 or 2 minutes, so that for those who have not seen, you can see. So then the preliminary site investigation. Then the detailed site investigation. Right. Then next question is explain about which should be included in a site investigation report as chapters. So what should be included in a report? Sorry, before that, for the previous question, you have to explain this one also. Plan a site investigation for a building or a reservoir or a bridge you prefer. So if you are constructing, or if you are planning for a building, planning a site investigation for a building, you have to mention that, and you have to explain these also. So these are the borehole layout if it is for a building, and large development area measurement, and the depth of investigation would be this. So likewise, you will have to, that is why you will have to explain. That is why I gave this kind of a question for your assignment, and the submission deadline is 15, so you have to submit it before that. Right. Then explain about which should be included in the site report. So in a report, what should be included? So first there should be an introduction, and then we have to mention. I think I have shown you a report. No? So let me see. I have one report to show you. Yep, I will show you one. So this would be one report that we have prepared, geotechnical investigation report. So the dates, now what they ask is the chapters, introduction, methodology, results. Now introduction, you will have to give an introduction, and then methodology, how you did this one, results, analysis, and the test results, conclusions and recommendations. Right? So you have to mention those things. Right. So that is regarding the site investigation. Sometimes there might be so many questions. So then we will be moving to the shear strength. So wait, I will share it. So the shear strength equation is tau F equals C plus sigma tan phi. And we will move to directly to the questions. I will discuss 3 or 4 questions here on the examples, but exercise. Yes, the first question. What is the shear strength in terms of effective stress on a plane? Blah blah blah. Yes. Read the question and please note down what is given, what are the factors given, or what are the values given. Then try to apply the equations and get the answer. I will just give you 5 minutes. So what you have to do is you can just apply that equation. Right. So this is the total normal stress, that is sigma and vertical, or the forward pressure is given. So the coefficient in terms of effective stress is also given, and phi dash is also given. So you can see the answer there. You can just apply that to the equation, because effective stress can be used. Effective stress can be found like this, and you can determine the shear strength just applying those equations. So shall we try this one, because I want to show you how you can draw the more circles. I think, did I show you yesterday? Sorry, it was not yesterday. The fourth. But okay, shall we move to the next question? So drain test, triaxial test, blah blah blah. All around pressure. All around pressure means the what is it? The sigma 3 value, right? That is sigma 3 value. The cell pressure. That is cell pressure. So the question would be, answer would be this one. Sigma 3 value is given. So this difference is principal stress difference, means the difference between the cell pressure and the vertical stress. Cell pressure acts horizontally, and the normal stress or the vertical stress is acting from top. So this is sigma 3, that is the horizontal force, and this is the difference. So if you need to take this sigma 1, that is the vertical normal stress from the top, you have to add these two. So when you, this is called as the deviator stress also, right? Sometimes it is called as the deviator stress, so that you can add these two to get this, get sigma 1. So then we will see how you can draw these circles, because you now you have sigma 3 values and sigma 1 values, right? So now we will see how you can draw more circles.
We will solve numeric.
So let me show you we have seen this one earlier, please let me know.
Numerical related to Mohr circle. So this is the first numerical. Following are the results of undrained triaxial compression test on two identical soil specimen at failure. Determine the cohesion and angle of shearing resistance with refer to total stress. So two soil sample is given to us, and this is their failure values. Sigma 3 is equal to 100 and 300. Sigma 1 is equal to 440 and 760. So now we will draw Mohr circle with the help of these values. Sigma 1 is 440 and 760. Sigma 3 is
Just the sigma 1 and sigma 3 values have to be found, right?
100 and 300. We no need to use this pore water pressure value here. On x-axis, normal stress, and on y-axis, shear stress is drawn. Here, 1 centimeter is equal to 50 kilonewton per meter square. Now sigma 3 value is 100. Sigma 3, we will consider first sample here. This is the first sample's reading and this is the second sample reading. So in first sample, sigma 3 is 100 and sigma 1 is 450. So sigma 3, first we will plot sigma 3 on x-axis. Sigma 3 is 100 and sigma 1 is 450. So this is sigma 3 has been plotted. Now sigma 1 I have to plot 440. So 440 means this is 400, this is 450, 450 somewhere here. So I have plotted 2 points, sigma 3 and sigma 1. Now I have to draw Mohr circle. First I have to take the center of this. First I will measure the distance between the 2 points. After that I will take distance in my protractor.
So this is how you can draw that circle, right? Because you have only two values. What is the arc edge of the diameter
between these 2 points.
So you can draw one more circle like this. I just wanted to show you this one because we could not do the practicals.
Okay, arc has been drawn between these 2 points. This is sigma 1 and this is sigma 3. Sigma 1 is 440 and sigma 3 is 100. Now I have to use second sample. In second sample, sigma 1 is 760 and sigma 3 is 300. So I have to plot 2 points, 300 and 760. So first I will plot 300 on x-axis. 300 is here and 760.
Now these are the sigma 3 and sigma 1 values, right? So you also, it is better to practice these during your study. Otherwise in the exam you will not be able to do it.
Is 600, 700, 750, 760 somewhere here. So now I have to plot the center between these 2 points. So distance between these 2 points is 9.4. So half of 9.4. I have to consider half of 9.4. Here we got the center between these 2 points. Sigma 1 is 760 here and sigma 1 is 760. Sigma 1 is 760 here. This is the first point and second point is 300. Sigma 3 is 300 here. Sigma 1 is 760. So in these 2 points, I have selected one center, and with the help of this center, I will draw one arc, semicircular, one semicircle between these 2 points. I got these 2 points now. Now I will, with the help of this 2 semicircle, I will draw one tangent touching to this point.
So that is how you can match this, the trajectory. You can draw the tangent, right? So that is how you can do it.
This is the cohesion. This is the value of cohesion. This is called C. And this is the angle phi. I have to measure this angle phi. Now we will measure what is the phi and what is the C. Phi is equal to 15 degree. Phi is equal to 15 degree. Phi is equal to 15 degree, and C is equal to 110. So this is 50. C is equal to, this is 1 centimeter is equal to 50 kilonewton per meter square. This is 100 and this is 10. So C is equal to 110. C is equal to 110 kilonewton per meter square. Second numerical related to the Mohr circle. A direct shear test is run on a medium dense sandy silt. At failure, normal stress is 65 kPa and shear stress is 41 kPa. Draw Mohr circle and determine angle of shearing resistance, principal stresses at failure, major and minor principal plane. Here type of soil is sandy silt, and at failure normal stress is 65 and shear stress is 41. Again same, on x-axis normal stress has been plotted, and on y-axis shear stress has been plotted. So shear stress is 41 given to us and normal stress is 65. So plot 65, 60 is here. Again here 1 centimeter is equal to 10 kPa. 1 centimeter is equal to 10 kPa. So normal stress is 65 here, 50, 60 and 65. And shear stress is 41. So 40 is here, this is 41. Join these 2 points. We'll see where it intersect.
So this is regarding direct shear test, right? So the graph sheets will be provided.
See here. So these 2 points intersect on this here. This point. Now with reference to this point, draw one line touching to the 0, because this type of soil is sandy silt, so cohesion is 0. That's why line has been drawn. So this is the failure envelope. This line is called failure envelope.
So that is the failure envelope for
now with reference to
Coulomb
this
failure envelope
point and this line, draw 90-degree with reference to failure envelope, plot 90-degree. So here is the 90-degree. Join this point. We will get center. So this is the center of the Mohr circle. This C is called center of the Mohr circle. Take this distance in protector and draw one semicircle touching to the failure envelope. So one semicircle has been drawn touching to the failure envelope. Extend this line and with reference to this point again join this point, and with reference to this point again join this end of the curve. This line is known as major principal plane.
right,
and this line is known as minor principal plane.
So that's it. We will see this question. So that is how you can draw these Mohr circles and match this, right? So since this is sand, the cohesion will be 0, and you can use this set of coordinates, this one and this one. So actually they have drawn only 3 Mohr circles. You can draw 4 out of these. Right? So could you please complete it, and if you have any questions, please ask now. So the next question would be again same kind of thing, but here you have to find Cu and undrained one. Cu means undrained shear strength and phi u. Right. You can draw the Mohr circles for this one also. Just quickly draw it. So what is that top sound? Quickly draw the Mohr circles. Right, I will show you the answer. So, what is the question number 4.3? Yes, this would be the answer. Okay. So there's an interesting thing here. The failure line is horizontal. The failure line is horizontal, and Cu value is 110. This undrained friction angle is 0 because the gradient is 0. And the Mohr circles would be something like this. Right, shall we move to the next question? We will be discussing only few questions, right? Yep, this is the next one because you have the forward pressure here. So the first thing is you will have to find this C dash phi dash. So yes, first find it, then we will move to the next question. So this would be the answer. So C dash would be 0, and so this will be the table, and they have drawn this 4.5. Yes. So the next question is very interesting. So you can complete up to this point. So any questions regarding this one? Then we will move to the next question. That is very interesting. If a specimen of the same soil, right? Same soil means the parameters are same, were consolidated under all-round pressure of 250, and the principal stress difference applied is 350. That means this is sigma 3, and the difference delta sigma is 350. Then the addition would be sigma 1, right? Sigma 1 would be 600. What would be the expected value of principal stress difference at failure? Right, that is interesting. And so the principal stress difference at failure depends only on the value of the all-round pressure. So that is 250, and by proportion the expected value is 250. Sorry, 170. So this is 250 somewhere around this one. So you can draw a more circle like this. You can draw a more circle and you will be getting it as 1/7. So that kind of questions will be there in the exam. That is regarding the shear strength, and so let me see. So let's take a consolidation question. So shall you try this 7.1, question number 7.1? So this gives in an oedometer test. This gives the results of an oedometer test, which is used for the consolidation of a saturated clay. GS is given, and the applied pressure was increased from 107 to 214, and the following compression readings were recorded. Gauge reading is there, the time, and gauge. That means the time from 16, 25, blah blah blah, and the gauge readings is given. So after 1440 minutes, the thickness of the specimen was, the final thickness is given, and the water content was this one. Right? Determine the values of the coefficient of consolidation and the compression ratios. Right. Now how we can do, you can just go through the note and see we have done there. So it is better if we can, if I will move to the question, sorry, answer. I have uploaded these two PDFs, right? So that you can refer them. Question number 7.1, problem number 7.1. Yes. First, you can find the total change in thickness. I will explain you. Yes, the root time plot. Then the delta H, that is 7.82 minus 6.02. So yes, the average thickness can be now gauge. This is the gauge difference. So the final gauge would be 6.02 and this one. And the average thickness of the sample was 15.3 plus this divided by 2. So this will be the average thickness, and the length of the drainage path will be double drainage. So it is this average thickness divided by 2, and root time plot, that is 90 square root of 90 is T90 is 3.3. Then the T90 becomes 10.9 minutes. So you can determine CV from the this is taken from this Q figure. So how would you draw this one? Sorry, first of all, you can come up to this point. Otherwise, the, we will miss that. So come up to this point, the length of drainage path. So then we can plot this root time plot, that is figure Q 7.1a, this one. In the x-axis we take the square root of time, and in the y-axis we take the dial gauge. So you can take the square root of this time, because it is given, so that it will be very convenient to get the square root of this one, this one. So it is very easy to get the square root of time. So you can take the square root of time and the gauge reading, you can plot it. So could you please plot it? I will give you just 4 or 5 minutes. Even though you have graphs, you don't have graph sheets now, you can just draw it. Otherwise, in the exam, you will not be able to do it. So that the total displacement or the gauge value will be this. 90% will be this one. So the 90%, the square root of T90 value will be 3.3. So that is what is taken as 3.3, right? So the T90 would be this. So for the T90, you can apply that TV equals TVT over D squared. By applying that one, you can determine CV. So from this is from the root time plot, and if you plot the log time plot, so log time plot, this one will be sorry. So here in the x-axis we take the log value of the time, and in the y-axis the dial gauge reading is taken. So for this one you will need the semi-log sheet. So from this one you can take T50, 50% of this one, 50% of the settlement. So that will be somewhere here. So from the time log time plot, you will get it as T50 as 2.6. So again using this one, you can find the T50, and then find the CV value. Right. So then let's move to this kind of a question, because this kind of questions will be there in the question, right? Read the question and draw a figure. So first thing that we have to do is you will have to draw a figure, 10 meter depth and overlies blah blah blah. So what you can do is you can draw a figure and then you can determine calculate the final settlement. So for this final settlement, what you can use is mv delta sigma h. The equation is mv delta sigma h, and first you should measure or you should calculate the delta sigma value. At the top of the clay layer, the decrease in pore water pressure is 4 gamma W. So the decrement of the pore water pressure will be this one. At the bottom of the clay layer, the pore water pressure remains constant. So the average difference would be this plus 0 divided by 2, that is 2 times gamma W. So delta sigma value will be 19.6, and the final consolidation settlement would be mv delta sigma h. mv is 0.83 as given in the question. So that is 0.83 meter squared per meganewton. Right? This is meganewton, and 0.83 meganewton, and this should be multiplied by 19.6. So that you will get the answer in millimeters. Right? So then the next one is assuming no change, settlement in 2 years. Right? Right. Then we will move to the lateral earth pressure. So let's discuss this question number 6.1 and 6.2. So first we will do the 6.1. So read the question and draw a figure. Sorry, I could not share it. No. So let's try this question. So first, what you can do is you can determine the Ka values. Ka, and then you can determine the active force, and then you can determine the pressure force. So what they ask is the approximate value of thrust. So you can use the active force equation, half Ka gamma h squared, to determine this. So if you have any problem or you have any questions, please ask them. So the next question is, what the distribution of the active pressure on the wall surface shown in figure 6.37, calculate total, right. Then we have to show the distribution of the active pressure and then calculate the total thrust on the wall. Total thrust means the total thrust force. So they ask for the force and active plus for its hydrostatic, that is the total force, and determine its point of application. Point of application is across the centroid of the polygon. And yes, first we will draw the figure 6.37. Yes, this would be the figure. Yes, okay, this is the figure. So please draw this one so that you can start the active pressure meter at this side. So you can start that. So then we will see the answer. So question is draw the pressure distribution. So you can first determine the Ka values. First determine the Ka values, and then the Ka1, A2 likewise. So you have three friction angles, so you will get three Ka values. So after that, you can determine the stresses at each and every point at each depth. Now at the depth of 5 and 8, you will get two values because that is the changing point of two materials with two friction angles. So just above this layer, you will get this one, and just below the values will be different. Right? So finally you will get the total cost as 571. So you can refer this one, you can check your answers. So if you have any questions, please ask. So I think you also get the same value. So the next question is, a line of sheet piling is driven into what table is at the surface. The unit weight is given and all the values are given. What they ask is to calculate active and passive pressures. Now we have to find the passive pressures also at the low end of the sheet pile. And all the values are given. So we will give a try to this one also. So this will be the answer. So in the earlier one, we will have to plot this. So this is what I told you, that the at one location, at one particular location, the lateral pressure changes quickly because of the change in the friction angle. This would be the hydrostatic pressure, and this play at this location, just above the point, it will have a higher value, and just below it will have a lower value. And this point also, just above it has a lower value, but just below it has a higher value because of the change in this friction angle. So this would be the answer for the previous one, the graph. So for the next question, you can determine K, Kp values first. Then you can do the calculations. Then you can determine this you can determine these forces. So the momentum, then you can take the moments also. So please check whether you have got the same value. So then for the next one, I will discuss a pile foundation question. So for that I will use previous presentation. So allowable pile capacity, as you have learned, that will be the total load carrying capacity, and you will need that one when you determine the allowable limit. So the question is, a driven pile in clay is shown in figure 18.2. The pile has a diameter of this much. I calculate the net carrying capacity using this equation. These are the things that are available in the PDF that I have shown you. And using the lambda method, beta method, and phi r is 30, and net allowable pile capacity is we have to find it for the factor of safety of 4. So this is the summary. This is the summary. Don't we have sounds here? Right, okay. So the ultimate Q ultimate, or the ultimate bearing ultimate capacity is equal to Qs plus Qp, skin friction plus the point load. Point load can be found like this: P times Q dash O, AP times 50 NQ star tan phi dash. And when you need to find the skin friction, you can find it as like this: sigma P delta LF. For sand, you can use this equation K sigma naught dash tan delta, and for the clay you can use lambda method and beta method, right? So using this or using this, you can use these equations. Yeah. This is how you can find the alpha value. Or else, this is the basic equation that we have discussed. So using this, and there are so many NQ square can be found using this graph. And the exam we don't know whether we will be given. So this kind of a question will not be there. The exam you know the graph is given over the table. And this is what we discussed about that critical depth. After the critical depth, the point bearing in the increases, and after the critical depth, the bearing will be constant. And this is what we learned in. These are the equations that we discussed. It's value for the sand. It means the frictional resistance. I think you know we have learned this one. Make it right? Right. Then for the piping sand, this Qs plus Qp can be written like this. So this is the I think it question. Will be now clear for you. Now here so we have a loop granular, and then dense gravel, and then at the bottom you have clay, glacial clay. දැන් අර ඉස්සෙල්ලා මේ ප්‍රශ්නේ ඩිස්කස් කරමු කිව්වා So this is an example question. So in the top you have loose granular soil, then the dense gravel, and then glacial clay. And I have to discuss some pile testings. That is why I selected this one. Yes, pile load test. Here at the top we have a loose granular soil, and then dense gravel, and then at the bottom you have clay, glacial clay. Like our research, this is very important one, pile load test. So now we are talking about the pile load test. Sometimes there will be a question regarding this in the exam. The most precise way of determining a pile's load capacity is the pile load test. So it may be conducted on a driven pile or cast in situ pile, on a working pile or test pile. So on a single pile or a group of pile. So why do we need these pile load tests are conducted? First one is to determine the settlement under working load and to determine the ultimate and safe load on the pile, to verify the structural soundness of the pile and as a proof of acceptability. So when you have a pile, when you need to accept it, what we do is we do these pile load tests. So then the design of files shall be based on one of the following approaches. So when we design the files, so the design of the files will be based on result of static load test, then empirical or analytical calculation methods. So I am not going to design them. So these are the photographs showing that the jacks, beams and piles, and this is how the test is being done. They apply a load from the top. And the maximum load is being captured. So you can see the photographs here. on the pile, the load is applied. So this is another one. So you can see how the piles are being loaded. So you can see it is load test is 6,000 tons. And basically there are two types of load test: MLT, that is maintain load test, and the constant rate of penetration test, CRPT, MLT and CRPT. In the maintain load test, the load is applied as series of increments, and each increment, that is the 20% of the expected design load, is maintained until the rate of settlement becomes 0.2 millimeters per hour. So the load is applied or maintained, that is in the maintain level. Each loading step may require 1 to 2 hours for stabilization, and the final load is maintained for 24 hours. Ultimate load equals, use that, you can use that equation. And the CRPT, constant rate penetration test, the pile is jacked towards at an constant rate of penetration. So the pile is jacked downwards, and at 1.25 millimeters per minute in some that vary from the soil and soil. Ultimate pile load is the load at which either shear failure takes place or penetration of the pile equals 10% of its diameter. So that is how it is being selected. In an end bearing pile, the features of CRPT, that is quick, so there are basically two types, MLT and CRPT, and these are some. The next thing is the negative skin friction. So sometimes there might be a question in the exam. Sometimes there might be a question in the exam. What is negative skin friction, or NSF? When a soil layer surrounds a portion of pile, shaft settles more than a pile. So what happens is this particular soil amount goes down with more than the pile. So what happens is the friction happens downwards. So that is called as negative skin friction. This consolidated layer, as you can see, that consolidating layer goes down more than the pile. So we will use this particular video to show you how it moves. So this will be the pile. On top of the pile you have the pile cap. Then at the bottom you have the firm ground. the load is applied from the top, and that load is transferred to the firm ground like this. And there are some files which gives a load of upward force. Upward force means relatively upward. When the soil layer goes down, then what happens is the relative to the soil, the pile goes up. So the skin friction occurs like this.
And sometimes there are some forces that the building is dragged downwards. Maybe building the skin friction should be actually the skin friction should be upward. Friction is really. However, the negative skin friction occurs down. So partially, the building gets settled. The building is our settled. That is what happens. The negative skin friction. What happens is, here, can you see my mouse point? Where are you?
Yes, sir. Yes, sir. We can.
Right. Then that means here the negative skin friction is down. You will see the results later. And the weight downward, perpendicular reaction, or the bearing effect, load at the bottom, and the skin friction. And then if the so-called loose layer settles after 5 has been installed, skin friction develops in this zone. Is the direction of soil. If a soil or loose layer settles after 5 has been installed, so in the method, if there is a loose sand, here, what happens is, if the soil layer settles down, then what happens is, when the soil gets down, or when the soil settles down, when the soil settles down, it drags the pile also down. The soil pile that is one method. What is the pile down? Therefore, this is one method of the negative skin friction. And these are there are three main reasons for the negative skin friction. There are two and there are one. First one, when the field of clay is filled over granular, here you have sand, and on top of that you have a clay area. Then what happens is, with the time, the clay settles. Clay layer settles. When the clay layer settles, what happens is, there will be downward force. also the KNA when this KNA settles, what happens is there will be a downward force happens. When the field of granular soil is placed over soil properly. And the next one is the lowering of the ground. When the groundwater is lowered, what happens is the effective stress. The effective stress is down. And from that also, what happens is there will be a downward. In this case, what we have is to find the negative friction, the equation. But just to keep in mind that there are some equations, you will not be able to find the negative friction. Just keep in mind that there are some equations like this to find the negative friction, right? And the effect of negative friction, that is the most important one.
So this is the effect of negative skin friction. So due to the negative skin friction, there will be the excessive settlements. And how we can reduce the negative skin friction? You can apply some bitumen in the pile so that you can reduce the friction, right? So you can apply, or closely spaced piles can be added. So that is how we can that is about the piles, and that is about just going through the sections. So that concludes the sessions. And as I have mentioned in the starting of today's session, I have mentioned the format of the question paper, exam paper. So at the beginning, so you can those who are not there, you can see the recording at the beginning of today's session. We discussed the what is it? We discussed the format of the paper so that you will be able to see it the recording. And I don't know the timetable yet, but the exam paper would be a very easy one, but the questions will be based on the basics, right? And any questions? There will be a graph sheet given and some supplementary notes also, as I have shown you during the exam. Sorry, during the lecture. The assignments have to be submitted before December 15th, as I can remember. Right, if you don't have any questions, then we can wind up the session, and all the best for your exam.
Thank you, sir.